Hello students, welcome to my channel Explore Physics, Let's Explore. In the previous classes I've explained you about the image formation in spherical mirrors. Today we'll be talking about the uses of spherical mirrors, new Cartesian sign convention, mirror formula and the magnification. What are the uses of spherical mirrors? Let's start the class with this. So, uses of spherical mirrors. We'll start with the concave mirror first. Where do we use concave mirrors? So, the concave mirrors are used as the makeup mirror used by the ladies. It is used as the shaving mirror. It is used by the dentist. It is used as reflectors, in headlights of cars and automobiles. It is also used in searchlight because it gives the parallel and strong beam of light. It is used in solar furnaces as well as in solar cookers. So there are so many uses of concave mirrors. What about the convex mirrors? What are the uses of convex mirrors? So convex mirrors is used again as a reflector. It is used as rear view mirror in the sides or in the front of the automobiles. It is also used in reflecting telescopes. So it is also used as a security for security purposes or in the parking area because it gives you the wider vision and the straight erect images of the objects. So there are different uses of concave and convex mirrors depending upon the use the object is placed. For example, if the dentist use it, or the ladies or the gents use it as a makeup mirror and the shaving mirror, then the object has to be placed very close to the mirror so that the object lies between P and F, and we get the erect and virtual, the larger or the magnified image of the object. So that is how we use mirrors for different purposes. Now I'll explain you about the new Cartesian sign convention, students. This gives us the sign convention or the signs which are to be taken for the measurements of the position of object, position of image and the focal length, and this we are going to use for the numerical problems. What does it say? So if we have a concave mirror here, and say this is the P, the principal focus. We have the center of curvature, say it's here, and the F here. The direction of incident ray is this. So according to the new Cartesian sign convention, first point that the object is to be placed left to the mirror. So the object is to be placed to the left of the mirror. 2. All the measurements which are taken along the direction of incident ray are positive. So if this is the incident ray which strikes at the mirror, so this direction we are going to take is positive. You can relate it to the positive x direction. So all these directions are taken to be, all these measurements are taken to be positive. Opposite to that, it is negative. So this is, you can just relate it to plus x axis and minus x axis. So the measurements along the direction of incident ray are taken to be positive. So the incident ray direction is taken to be positive. 3. The measurements
above the principal axis are taken as positive. Now you relate it to plus y and minus y axis. So if the object is here, so this will be positive. So the measurements above principal axis are positive. Then measurements below principal axis are taken as negative. So if the object is here, say beyond C, this above the principal axis, we are going to take the size of the object as positive and the image will be formed here. So this will be taken as negative. So the image formed which is below the principal axis will be taken as negative. So this is all about the new Cartesian sign convention. One, then object, which is the object is to be placed left to the mirror. Two, the measurements along the direction of the incident ray are taken to be positive, this direction, plus x-axis, minus x-axis opposite to that is taken as negative. Measurements above principal axis are taken as positive and measurements below principal axis are taken as negative. One very important thing is measurements are to be taken from the pole of the mirror. From the pole of the mirror. So, whatever we are taking the measurements, if say this is the, let's assume this is PO, PO is the position of the object, so we'll not be measuring it as OP, we are going to measure it as PO, we'll have to start from P. Same if this is IP, the image distance, then we'll be taking it as PI, so we have to take the measurements from the pole of the mirror. So this is all about the new Cartesian sign convention.
So here we have the formula which gives us the relation between U, V and F. And what are these? Say we have a mirror again. This is pole. This is the principal axis. Say this is C. This is F. So let's assume the object is placed somewhere here. So the distance between the object and the mirror is referred as U. What is U? The distance between the mirror and the object. Let's assume the image is formed here. So the distance between the image and the mirror is referred as V. So what is U? The distance between the object and the mirror. What is V? The distance between the image and the mirror. What is F? The focal length. You already know that the focal length is referred as small f. So U, V and F, and the mirror formula gives the relation between them, that 1 upon F is equal to 1 upon V plus 1 upon U. This is referred as mirror formula, which says that 1 upon F is equal to 1 upon V plus 1 upon U. Let's take the example and then we'll see what will be U, V, F in this case. So let's take one example when I'll take the example when the object is placed at C. Okay, so we'll take the example where the object is placed at C. So where will we show this U, V and F? So if you just recollect, we have taken one object here. Out of 4 line arrays, I have told you only you have to take 2, any 2, minimum 2 rather. It goes parallel to principal axis and after reflection goes through F. After reflection goes through F. One ray, you can take the one which goes through F and after reflection becomes parallel to principal axis. So this is the ray here. The image is formed, I'll write C here. The image is formed here, same sized. The image is same sized at C, real and inverted. So where do we show the U? So U is the distance between the mirror and the object. So this will be referred as U. V is the distance between the mirror and the image. So this will be referred as V. This will be referred as V. And F is the focal length. So this FP is the focal length. So this is how we have to use the formula 1 upon F is equal to 1 upon V plus 1 upon U. Out of these 3, if we know 2 symbols or about 2 measurements, definitely we can find the third one. So this is about the mirror formula. Remember, in mirrors, this is the plus sign here, positive. Okay, in lenses it is negative. We'll talk about it a little later. So this is the mirror formula. What is the magnification? Magnification tells us how big or small is the image as compared to object. To which extent the magnification of the object is here in the images. Whether if it's in minus, so naturally if it's less than 1, then it is smaller image. If it's more than 1, then it is the bigger, the magnified image. When we come across in the numerical form, it's easier for you to understand. So magnification is shown by small f, and this is equal to h dash upon h, or I can also say that is equal to h dash upon h is equal to minus v by u. Again, the derivation is not here for 10th standard. If you go to 12, the complete derivation for this formula and this formula is there. So the magnification is equal to h dash by h, where h dash is the height of the image. Here this is h dash. H is the height of object. Here height of object. V is the distance between the image and the mirror, and U is the distance between the object and the mirror. So M is equal to h dash by h is equal to minus V by U. It tells us to which extent the image is magnified, whether it is plus or minus. It has its own relevance or symbol for that. We'll talk about that. So if M is, say, 1. M is 1 means same sized image. If M is 1, that shows that it is same sized image. If it's negative, then it is real images. If it's after solving it, if it comes out to be negative measure, then M is that image is real. When it is real, it has to be inverted. When M is positive, it shows that the image is a virtual image. So these are a few things you should remember. 1
when it is same size, when it's m is equal to 1, it means it's the same sized image. The size of the image is equal to the size of the object. When m is negative, it means the image formed is real and inverted. When m is positive, it tells us that the image is virtual and erect. Same size, when it's m is equal to 1, it means it's the same sized image. The size of the image is equal to the size of the object. When m is negative, it means the image formed is real and inverted. When m is positive, it tells us that the image is virtual and erect. So this is all about the magnification. What did we discuss today? 1. The uses of spherical mirrors, that is uses of concave mirror and the uses of convex mirror. Then we spoke about the new Cartesian sign convention. I've explained you here how do we take measurements. You have to remember 5 points for that. All the measurements taken towards plus x axis are taken to be as positive and to minus x taken to be as negative. Plus y, all the measurements taken along plus y axis are taken to be positive. Measurements taken along minus y axis are taken to be negative. All the measurements are to be taken from the pole. And the measurements taken along the direction of incident rays is taken to be positive, and opposite to the direction of incident ray are to be taken as negative. So this is all about the new Cartesian sign convention. Then I told you about this mirror formula that gives you the relation between u, v and f, and what is u, the distance between the object and the mirror, v, the distance between the image and the mirror, f is the focal length of the mirror. Then we spoke about the magnification m, which equals to h dash upon h, where h dash is the height of the image formed, h is the height of the object, is equal to minus v by u, where v and u already have discussed about it. Then I told you that if m comes out to be 1, it means the image is of the same size. Like for this example, this particular case, when the object is c is same size, so m is 1. But it is real and inverted, so m will be minus 1. Okay? So m is equal to 1 means same size image. When m comes out to be negative, that means that image formed is a real and inverted image. When m comes out to be positive, it shows us or it tells us that the image formed is virtual and erect. So this is all about what we have discussed today. That's all for today. Stay healthy, stay safe, and a very big thank you to you all.